leveraging the European experience, microbial fertilizer addressing Thailand agricultural challenge. Floor is yours. Short introduction before starting the meeting.
Thank you for this opportunity. It's a big honor to be here in a new region for us. So instead of introduction, I will show a very brief video for 1 minute.
We are BTU, a biotech company that produces biological products for plant nutrition and protection. And we want the Earth to stay alive. That's why our production never stops. With 60 state-registered bioproducts in use, the Institute of Biotechnology works tirelessly, as do our warehouses and cooling systems. Our dedicated logistics fleet works around the clock and transports products to 20 countries worldwide. Our scientific team and more than 500 employees work. The microorganism bank works. And the microorganisms themselves do their part as well. We've got biofertilizers, biostimulants, biofungicides, bioinsecticides, and so much more. Everything works to protect plants, increase the harvest, and keep the earth alive. BTU. Nature works.
So that is instead of introduction. So we are a company from East Europe, from Ukraine. We are more than 500 people, 26 years old. We have extensive experience of use of biologicals in field crops, treating more than 4 million hectares each year. And of course we work with biopesticides as well, but here I would like to focus on some biologicals which could be used in regenerative agriculture and in biostimulants and biofertilizers. Again, we are quite data-based company. For each claim we try to gather the data which proves it, and today I would like to speak about a few directions. So the first direction is about carbon management or carbon sequestration. We have developed a formulation which is a complex of some bacteria and fungi, including some anaerobic fungi which accelerate decomposition of after harvest residues and thus enrich soil with carbon. I will show you the data what we have in this direction. Second direction are the biofertilizers, so known nitrogen fixing products, phosphorus solubilizers. Again, we have extensive experience to substitute a particular amount of NPK and to improve the nutrients use efficiency in diverse conditions. Again, I will show you some examples of that. Then one of our quite unique solutions is deploying microorganisms to produce natural polysaccharides, which we use as a kind of adhesive agent or an adjuvant in agriculture, but also due to richness with metabolites of bacterial region, it also acts as anti-stressant, especially in drought conditions. So that would be the last point. So first of all, as I mentioned, we do tons or thousands of trials, more than 2,000 of them, and we gathered all the data in one big database and try to analyze it to understand what average results we have. So in this database, we get more than 90% positive trials with average increase of the yield more than 10%. And speaking about the crops, we tested them. So mainly we work on field crops again, but we can see that the potential in high-end crops, vegetables and root crops is even higher. Then we also work with different categories of biologicals. For example, we work with nitrogen fixers, phosphorus stabilizers, mycorrhiza, products for decomposition of plant residues, also different combinations, inoculants. But what is interesting from this database, for example, you can see that from application of micronutrients, who probably you all work with, you can expect in average like 10-11% of increase of the yield. So the similar effect you can expect from nitrogen fixing and phosphorus stabilizing products. Then we also study different methods of applications of biologicals, seed treatment, soil treatment, treatment during vegetation. And what we can see is that, for example, the most efficient is using biologicals into soil and foliarly, but the also quite economic way is to treat the seeds and apply biologicals foliarly, because normally dosages for seed treatment are quite low. Then also we have nearly 1,000 trials with indication of pH level, and from this we also can observe that In general, biologicals work in different conditions because very often when we come to some markets, they say, okay, we have very acidic soil, we have very alkaline soil, so probably it will not work. So from our experience, still critical conditions, like you can see here, even in neutral conditions, when everything is going well, potential of biostimulants is even lower. Then let's go to some of the solutions. So first one would be EcoStern to improve soil health properties. So as I mentioned, it is a complex product with some bacteria like bacillus, different strains of bacillus, but also nitrogen fixing bacteria and some anaerobic bacteria, and also trichoderma strains. Normally we apply it in the end or in the beginning of the season on the degraded soils, or just in order to accelerate the composition of plant residues which are difficult to decompose, like corn, cabbage or rice. I will also show some examples. But there are some interesting directions of use of these products, for example, after flood or again on degraded soils, which I will explain. So some amount of data. As you can see, we started studies with this product almost 15 years ago, and even at that period of time we had a focus on organic matter because a kind of integrative indicator of soil health and productivity. And in this case you can see that in a 4 years project we reached to enhance organic matter accumulation up to like 0.2%. Besides that, we did some studies to evaluate the speed of decomposition of different plant residues on different kind of soils. And thus, when you accelerate carbon sequestration, normally you also have a positive influence on density of the soil. Again, this product is applied already on millions of hectares. And in Ukraine, we have a big companies who have 500,000 hectares or around that. One of such companies is company Kernel, who is our strategic partner, and they say there is no field on their 500,000 hectares farm which was not treated with EcoStern. So they did some long-term studies by themselves as well. In this case, 3 years, they applied different formulations of EcoStern, and in comparison to control, the average increase of organic label carbon content in the soil was plus 0.19%. If we recalculate this amount to amount of organic compounds per hectare, it's more than 6 tons, and also it's possible to recalculate that to amount of sequestrated CO2, and which is more than 8 tons per hectare. So with this data and instrument, we are also working to make this product available in the carbon credits program. So one of the important directions of application of this product is recovery of the degraded soils. As you know, now I hear about the challenges of agriculture in this region. Sometimes you have too much water, and then you have floods. Sometimes you don't have water, then you have drought. So speaking about floods, it's quite a negative story for soil properties, because when there is flood, soil has no air, and microorganisms die, and that soil is not productive. So our intention is to return functional microorganisms to the soil, so that carbon sequestration, nutrients assimilation can take place. So to visualize this, we use one Japanese method which is called Biofertilizers, which measure enzymatic activeness in the soil. So as you can see, on sterile soil there is no any activeness. And then when we apply the normal dosage of EcoStern to the solution of soil, we return its functionality almost to a normal level. With this method, we also did some field studies in Germany on regenerative farms. They are initially quite in good conditions, but we succeed to improve their activeness from 10 to 30%, and also we improved the functional biodiversity of the soil. So then coming back closer to Thailand and regional crops, we have some studies with rice. So again, rice is quite difficult to decompose the straw of rice. That is why it can harm the next season's crops. In this case, we tested soybeans after rice. And so what we checked? First, we checked that when we use EcoStern, the amount of straw grams per kilogram of soil decreased, and thus we improved the yield of soybeans, and also we can see that plant density and number of beans were better on soybeans, because again plant residues does not harm the growth of next crop. We had several such experiments where we improve the composition of straw of rice like up to 30-35%. This is how it looks like. Like if you take the straw, originally again it's difficult to decompose. Sometimes farmers in our regions use nitrogen for this aim, and again when we use EcoStern, it's much more likely to decompose, thus it does not harm growth processes of next plants. So next topic is biofertilizers. Again, it's a trend in direction, and here we have got a lot of a lot of data. So first product is Azoto Health. It's for product for nitrogen fixation. We work with also endophytic bacteria, Agrobacterium pucens. We have liquid and dry formulations of this product. And then we have Ground Fix, which is a product for phosphorus solubilization based on complex of bacteria. We start direction of nutrients substitution nearly 5-6 years ago with several studies on different crops like soybeans, sunflower, corn, and idea to substitute 30% of the fertilizers. So we reach quite positive results, which even overcome 100 NPK control in this case. But again, we try to be consistent and confident in our recommendations. That is why we continue these studies, and now we have maybe 50 studies compensating different amount of nutrients. But let me focus on this one. So it was last year we take corn, and with normal like 60 kilograms of NPK per hectare. It was quite arid conditions, so the yield was quite low. But then again we have standard fertilization scheme with use of biofertilizers, and 30% less fertilization scheme with use of biofertilizers. So again we work with our formulations evolve. We have a classic version which we worked like 10 years ago, but the challenge was shelf life. Now we improve the shelf life. We develop a liquid stable formulation, which is like stable two and more years in warm conditions, and also a WP formulation, which is even more concentrated. So our aim was to see that our new formulations are even more efficient than the original one. And again, we can see that with use of these phosphorus solubilizers, we reach the yield which is even better than 100% NPK. So the similar idea or studies we have for nitrogen fixation products. So we have a standard like 120 kilograms of nitrogen, then 75%, 30 kilograms less. And then we tested different ways of application of nitrogen fixing products into soil with different dosages, foliarly, and dry improved formulation. So as you can see, like both ways are efficient to improve nitrogen use efficiency. Then also we start work with some new for us crops. For example, we have some data on cotton from last year in Greece, and here we reach quite sufficient increases of the yield, and cotton is quite expensive crop, so here economics was very promising. Then we have data not only from Europe, but we start some activeness in North Africa, GCC, and hopefully we will get some data here soon. So in Ivory Coast we got also experiment on corn, where we substitute 25% of NPK with use of Ground Fix and Azoto Health, reaching quite big growth of the yield comparing to control, like almost 30-40%. So thus, then there are different ways of application of biofertilizers. The basic and main one is before soil tillage, but also it's not always convenient to the farmers. They don't want to make separate application. That is why we got quite a lot now ways to apply it. For example, with soil herbicides. And what is interesting, we got maybe 20 studies when we have seen effect of use of biofertilizers on the next season after application. So it means the bacteria survive in soil and works for long term. And besides that, quite popular now is in furrow application, and for this again we work a lot on formulation to make it compatible with fertilizers and also with urea ammonium nitrate. So now a few words about drought tolerance and improvement of efficacy of applications. So one of the unique products by BTU is liposome, which is based on the polysaccharides produced by bacteria. It is registered as adjuvant, but we mainly prefer to call it sticking agent or adhesive. So it has a few functions. We apply it foliarly, thus it improves like quality of application, it improves rain fastness. So here, when you have a walk during the day, it's very not usual for us, because during 10 minutes you can have rain 3 times. I mean, I believe that in these conditions, quality of application and rain fastness of the solution is very important to have efficacy of what you treat on the leaves. So it's the second function. The third function, it also prevents leaching of herbicides. Fourth function, it's also improved drought tolerance of plants because of richness with metabolites and origin produced by bacteria. And in fifth feature is anti-cracking properties. We apply it on cherries, grapes to prevent cracking of fruit. So again, as we are focused on the improvement of each claim, we did some tests to visualize how products is performing. So first one on the left, you can see the test, how we checked the rain fastness of the solutions with liposome. So when we treat different leaves with liposome solution, and it starts raining after 30 or 60 minutes after application, we increase amount of retained solutions like from 50 up to like 200 and more %. Thus again you preserve what you have applied on the leaves. On some crops you have a wax layer on it, and it's difficult to make substance stick to it, and again it's sensitive to some fungal diseases or insects. So with liposome you can provide a good quality of application. And again we did some tests with tubes with soils to see how we prevent leaching of water from the soil. And again, during last 5 years, we do a lot of studies towards drought tolerance of plants, and we tested different biostimulants, amino acids, humic acids, bacterial solutions. And what was interesting to find out that the best performer in terms of yield was our nitrogen fixing product Azotohelp, and the second place was liposome, even though it's just a kind of adjuvant. So then this give us intrigue and lead us to go to lab to see what is happening. And we analyzed also some biochemical and gene level reaction of plants for treatment by our biostimulants. And it's interesting to mention that liposome helps to preserve water in the plants, and also the use of liposome increased drought tolerance of plants. And when we measured after drought level of expressions of genes like reaction to the drought, we can see that with liposome it's much lower. Also, what is important for liposome, again, there are tons of adjuvants on the market, but for example, there are like oils, they can harm natural processes of plant, like evaporation or photosynthesis. Then there are some acids. Acids can harm the wax layer of the leaves and make it sensitive to pathogens and diseases and sunburns. Then there are some different, for example, silicone. Reduce surface tension, but then you have a lot of dripping of the solutions from the surface into the soil. Thus, it's also not completely efficient. And liposome does not have these disadvantages. And again, with this, for us, it's very important not only the hypothesis or work in a laboratory, but the practical experience and real impact in farms. In this case, we tested our solution with Azotohelp and liposome in field conditions on the sorghum in near Bologna region in Italy. There was flood, so really the germination was not so good. And then when we treat product and come for observation in July, it was plus 46, so quite hot. And in these conditions, we lead to increase the yield of sorghum, like almost 400 kilograms per hectare. So again, our This presentation and our experience tells that use of biologicals in a wide scale is possible. It really provides benefits quite consistently. So don't be afraid to use biologicals. There is a huge, not only theory and science behind that, but already a practice. So I hope that in this region, biologicals will continue developing efficiently. And we will be happy to help you with that. Thanks.
Thank you very much, Dmytro. It's very thorough and very interesting with your liposome actually. Just doing a great job. So we have a time for a few questions. Who is the first one? You want? Mike, please. Is there anyone? Okay. Come to the job.
Your liposome is a cell biological products, right? So it's also a bacteria. And what's the mode of action for drought tolerance, for improving drought tolerance?
No, it's a good question. And liposome is a polysaccharide produced by bacteria. So inside you don't have a live material. And as it is produced by bacteria, it also rich with metabolites of these bacteria. And our studies towards improvement of drought tolerance start like in 2020, very occasionally. Our scientists treat some flowers with liposome and see that they survive better after the weekend. Then they go into lab tests, do some treatments like they don't water the plants and see what is happening. And they see that plants treated by liposome survive better. Then we go into field for 3 years studies and do this some analysis to see the reaction. But the mechanism of action is clear, evident and deep. We are still investigating.
All right, thank you. Anyone?
Thanks, Dmytro. So you would suggest to apply the product through foliar spray or soil application or both?
If we come back to our database, we deploy different methods of application: seeds, foliarly, and soil. It depends on the conditions and the crops and the technology. Our aim is always to integrate biologicals into farmers' practice, not to create a wheel, but to make it convenient. That is why they could be different, and most of them are working, but sometimes there are some crazy ideas. For example, some of our partners, we send them mycorrhiza and they apply it foliarly. And I say, or in soil, I say it's like use a gold, you know, because it's very expensive zinc, quality zinc, which you need to put to the seeds or around the rhizosphere, not in soil. So still you need to be careful, but in general you can use different methods.
Thank you.
The time for 1 or 2 questions. Okay, if not, then I just have a reminder. So the next one is the networking session to start just now for half an hour, so we'll be back here. And then there is very interesting one actually. Afterwards, the 3 speakers will be there on that stage, and you will have the opportunity to ask as many as questions you want for half an hour. So it will be a very interactive session. I'm going